Source S emits microwave with a constant amplitude. The microwaves hit a metal screen and are reflected. The station wave is formed between S and P. The wavelength of the microwave is much smaller than the distance between S and P. This is a stationary wave formation. And we are moving from S to P. Saad is saying answer is B. So when you move this detector, there are back-to-back maxima and minima. There are back-to-back maxima and minima. As there are back-to-back maxima, minima, then it will increase. A student set up apparatus to observe the double slit interference of monochromatic light as shown. Interference fringes are formed on the screen, which change would increase the distance between adjacent fringes. This distance is called X. Formula is there. X is equal to lambda D upon A. This is the formula for Young's double slit experiment. Okay, one suggestion is B and one suggestion is A. Decrease the distance between the two slits. It is actually A. So when you look at the relation, X is inversely proportional to A. So when you decrease the A, when A decreases, X will increase. It is always safe in A level that you should see all the other options also. Width W has no relation with X. And move the screen closer to the double slit, then it will be the case of D. D decreases, so X is proportional, there will also decrease. Use light of a higher frequency. Frequency is not concerned directly here until you put lambda and frequency opposite to each other. So when you use higher frequency, you will use lesser wavelength. And when you see this screen, lambda and frequency, then you have to make a relation between which will increase the distance between adjacent screen. So when you say it's inversely proportional, it will not decrease the X. It will decrease the X. Why we want to increase the X? Remember that frequency and wavelength are inversely proportional. frequency and wavelength are inversely proportional. Now, look at this one. Monochromatic light of wavelength 690 nanometer passes through a diffraction grating with 500 lines per millimeter. So this is basically N in millimeter. Producing a series of maxima on a screen. This is lambda. The greatest number of maxima. So for greatest number of maxima, you can put theta is equal to 90 degrees. Formula says N lambda is equal to d sine theta. So we can first find, our N is in millimeter. So 300 lines, 1 millimeter. I want to convert it into meter. So if I say I have to put it 1000 millimeter here, and it will be 300,000 lines. So E will be equal to 1 upon N. So what is actually N coming after the calculation?
Sodium.
Answer is coming T, and we will put N lambda is equal to D, and then we have to put lambda. D is in our hand. Then we find the value. Achha, how much D is coming? It is coming to be 1 upon 300,000. And then lambda is 690. So what is the Asad, what value of N is coming from this calculation? If you people have done this calculation and you people have found the value of N, what value of N you people got?
One second, sir. Sir, it's 4.5.
4 point?
5. And then you have to times it by 2.
But I was thinking that Because if 4.5, I should double the option is the maximum option is, because if 4.5 are there, order n is 4.5, 4.5 and above and below. Then there is no other option of actually it should be 2n plus 1. But 2n plus 1 will give me 10, which is not the option actually. Why can an observable interference pattern never be obtained between two monochromatic beams of light from different lamps? The frequency of the light from the two lamps can never be the same. From different lamps, the light from the two lamps can never be coherent. Coherence is the primary condition. Frequency can be the same, but the problem is coherence, constant wavelength. So coherence is the fundamental problem when you deal with a question like this. Fundamental issue is coherence. If there is no coherence, there will be no interference. So now the first part, the temperature of the filament can never be the same. Temperature has no link here. Wavelength of the light from the two lamps must always be different. It should be the same. So now we have a tie between A and B. Yes. Sad your input and Ariba, your input also. Ariba, did you attempt that quiz? One question quiz.
Yeah, I did, sir.
Sad, how it can be B?
Sir, it's because like it says that it can never be coherent when they can be coherent, sir. If they have the
No,
same
no,
frequency.
two lamps. Sad, two separate lamps. Nearly impossible. Two separate lamps. Just like when you're driving a car, the front two headlights are exactly identical. Still, you never see an interference pattern in front of your car. So remember that when remember the idea why they thought about this concept, why they thought about the idea of double slit. Double slit was used because it is like a single source. It's just like you have changed now to P and okay, P is the right answer. The interference patterns from a diffraction grating and a double slit are compared. Using the diffraction grating, yellow light of the first order is seen. First order means n is equal to 1 at 30 degree. To the normal to the grating, the same light produces interference fringes on a screen 1 meter from the double slit. The slit separation is 500 times greater than the line spacing of the grating is 500 times greater. So I will say A is equal to 5,000 D. What is the fringe separation? So I will say I have to find X. I have two formulas in this question. X is equal to lambda D upon A. Second formula, N lambda is equal to D sine theta. Examiner says A is equal to 5000 D. So from here, I will make A the subject. A is equal to lambda D upon X. From here, I will make D the subject, N lambda upon sine theta. My plan is to use this equation. So if I use this equation and replace the values, lambda D upon A is equal to 5000 into N lambda upon sine theta. I can cancel lambda from both sides, and I have D as 1. I have small a. Sorry, it is lambda D upon X. One lambda is cancelled. What is X? Acha, X I have to find. N is 1 upon sine 30 degree. So you have to rearrange and find the value of X. Please get me the answer. So if you people can share me the answer. I need to find X. Oh, it is 500. Oh, sorry. It is not 5000. It is 500. Ariba is saying C. Okay, Ariba, how you got C if we solve this and N is 1? Right. Apparatus is arranged to show double slit interference using monochromatic light. The slit separation is 0.10 millimeter. The distance from the double slit to the screen where the interference pattern is observed is 2.4 meter. What is the new fringe width? Even though fringe width is not exactly the value of x, but I can take it x for the assumption center to center. And I can say this is my A1, this is my D1, this is my X1 to 1.8. This is my D2, and the slit separation is double. Slit separation was 0.1, now it is 0.2. This is X2. Okay, Sad, you have posted two answers, C and D.
Here, C was the for the last one. This is D.
And you said D. Have you made a ratio?
No, sir, I just calculated wavelength and substituted in the next one.
Then you put it back. Okay. So you complete this. Everyone should try to complete it. I'm taking a namaz break here, and after namaz break, we will start our theory work. We have done a good number of questions. So please complete it, and then we can start our current work. There is a short namaz break.
Sir, I already done my prayer.
Sorry, yes, sir.
Okay, sir, that's fine.
No, can you please repeat what you said?
Already done my prayer, sir.
That's good. Now just wait for a few minutes, and we are starting that.
Okay, sir.
This was we were doing this MCQ after putting the values of the values in the question. Please select your answer. The answer I am getting is B, 4.5 millimeter. Please check your answer. Everyone, please give your feedback. We have to start our other work. The data is in front of you, and you have you have to tell the answer. Okay, Saad, you are also on B now, right? Please, Ariba, if you have the answer, Noor, if you have the answer, please verify it. ठीक है. So the answer is B.